Thanks, everybody. This is a huge honor to be able to talk at ADC. Big reason for my excitement at being able to even talk today is a year and a half ago, Kieran, what's up? When we got started with building mayk.it, obviously ADC was a huge resource for helping us get up to speed and start learning a lot about everything we needed to know in terms of having a really robust audio infrastructure. And so really, really excited and glad to be able to talk today a little bit about our experience. I come from a little bit of a different background, so we'll start with a little bit of an existential slide. I actually got into audio development through a little bit of a roundabout way. I actually have a background in firmware development. I worked on the Snapchat Spectacles, building out their firmware, built a number of iOS apps that involved audio, but again, didn't go into the details of DSP or really any of the questions of like audio infrastructure and really managing audio buffers in the same way. And I'm an amateur folk singer. You don't have to watch my content, but if you do, I think it's pretty good. 114 followers on Twitch, NBD. And this is my Twitter, so feel free to tweet at me or talk to me at some point. But a little bit about what we built. So this is mayk.it. This is a song someone made on their phone. Astrally projecting me. So we basically pause it a little bit. It's really a bop though, so you should check it out on your own time. But it's a music app for non-musicians, meaning we basically focus on just what a beginner would need to get started getting to a song as quickly as possible. For beginner musicians, it's hard maybe to think about that experience, but they're opening up FL Studio or Ableton, right? They're looking for royalty-free beats. They go to some of the default plugins, and that's their experience of making music. And it's actually somewhat of a frustrating experience, especially if they're more focused on ideation, getting kind of ideas down onto paper, not really worrying too much about the final product. Normally, these are musicians that would pair up with a producer if they could find one, but a lot of the time they're sort of just on their own somewhere in their bedroom, trying to make sense of a complicated world of audio and not really able to go that deep into it without spending a lot of time just in the technical weeds. So we focus on really, a big one is pitch correction and other kinds of voice effects, little DSP modules that we built. Working with producers to get produced beats in the app and also figuring out better ways to help with sourcing beats and getting basically producers who have thousands of beats at home, a way for them to find vocalists that might want to jump on their track and make sense of that beat in a new and kind of unique way. We also have a lot of community features, which means like we focus on not just the ability to create these drafts, but also celebrate the drafts. So if someone comes up with a great draft, like astrally projecting myself into a comfortable chair, they can sort of rise the charts of drafts that are made on the phone. And finally, prompts and creative tools. So a big piece of how we differentiate is focusing on inspiration and feeling. So helping people kind of feel like they can get into making music even without any experience. So a little bit of background. When we got started, we had to make sense of like where to get where should we start thinking about code? How should we build? What technology should we pick? And so if you haven't really looked at the landscape of audio on iOS, and this talk in general is going to be a bit high level in terms of just technology and sort of the choices we made along the way. But in iOS, there's obviously CoreAudio, and that gave birth to a whole world of experiences that were built on top of CoreAudio. In 2012, Learning CoreAudio came out, helping people make sense of a sort of complicated API set. The amazing audio engine built on top of CoreAudio, JUCE built on top of CoreAudio, Superpowered built on top of CoreAudio. And then in 2014, Apple came out with a completely different framework called AVAudioEngine. And out of that, there was sort of a framework called AudioKit, which raise your hand if you're familiar with AudioKit in the room. Okay, cool. So most people are familiar with AudioKit, which is great. AudioKit is a sort of a Apple framework. So it's a iOS framework and also Mac OS built around AVAudioEngine. So when we got started, we started thinking, okay, let's get into CoreAudio. Let's start building on top of CoreAudio. And then saw this comment from the author of Learning Core Audio that said, the organization of this book doesn't make sense given the current media frameworks and given that I made about $4 an hour writing the last one. Once I divided my royalties by the time I put into it, I'm sorry to say a new Mac iOS audio book is not at the top of my priority list at the moment. So this book was already a little bit outdated when we got started. Mike Tyson from the amazing Audio Engine also sunsetted that in favor of AudioKit, saying for 99% of applications, an audio developer should think about using AudioKit. So we used AudioKit. And I'm here to say AudioKit's amazing. If you haven't had a chance to play with it, it's just a lot of fun to prototype audio experiences. You can think very high level, and it's a very strong community, and the community is really, this is sort of an initial version of our MVP built on top of AudioKit. And again, it's very easy to build with AudioKit. So we built this in a number of weeks, where you have the microphone input coming into a number of different audio effects that are all mixed together. We take the output of that mixer and record it. We also take the beat that gets played. We play that through an AK player, store that also. And then finally, the mixed output of the beat and the vocals together, we record it as well. And then you have sort of this recording flow that ends up with 3 different stems. You have vocals, beat, and then mixed output. And editing is very similar, except for instead of taking microphone input, you take some vocal stem, and you feed that into the same graph. And here you can see we have a number of different effects that we started building, and each of these at first was sort of just using what AudioKit came with.
What's up? How you doing today? Hey, what's up?
A little bit of CPU pressure on phones leads to a little bit of distorted sound. Great. Anyways, we got really excited about AudioKit. This is just to show that you could do amazing things very quickly with it on iOS. So again, coming from the iOS developer perspective, less from the audio developer perspective, AudioKit's a dream. So we built a lot of different fun little rhyming tools so that users could easily rhyme, and there you just need to tap the audio input. We created other fun ideas around modifying beats and Quick Create, where we basically let the user record a small audio sample and
I'm going to be doing nothing all summer.
And let you sort of create a whole song around a vocal snippet that you then later construct a song from. So we basically built this MVP fairly quickly and gave it to a lot of users and found that there's actually a large number of people out there who would consider themselves music creators but not musicians, meaning they get excited about an app that allows them to do this. So we quickly found a lot of people who loved it. A couple pieces of feedback that we got, the vocal effects just weren't that interesting. The default reverbs and bit crushers available on AudioKit are built from sort of, there's a guy named Paul Batchelor. He took a couple Faust modules, and then those are sort of the foundation of AudioKit's effects. So they wanted more complicated effects, more involved effects. And they also wanted it just to be easier to edit and record. So we didn't have at this point in time any abstraction of clips or tracks. Again, it was just come in, have fun with this app, record your vocal track, we'll add some vocal effect on top and mix it together with a beat. So we first knew we had to get into vocal effects in a big way. We had to jump into the weeds and start really understanding what was even possible from a product perspective. If we could build whatever we wanted for someone on their phone, what would we build? And that's where we started, again, modifying some of the SoundPipe code, which again, SoundPipe is mostly Faust. So they took, if you play with Faust and you compile it down, you can build these vocal effects very easily and plug them into AudioKit, and I'll get into that in a second. The other thing that we did a lot of was prototyping in Super Collider. So if you haven't played with Super Collider before, how many of you have played with Super Collider before? Okay, a healthy number. If you haven't, I highly recommend it. It's a really fun sort of workspace IDE that lets you really quickly start playing with pitch detection, pitch correction, UGens that you can there's a very active community around, and you can really easily get started with sort of just imagining or dreaming what you might want from your DSP code. So before you go into the details of the actual system you're working on, you can just sort of dream a little bit. And that was really cool for us. This is an early harmonizer that I built. It's very easy to build many different kinds of effects with the UGens of Super Collider. And all you really need to do then is translate the DSP code back into C++ at some point. And so we'll get into that because on iOS and Android, you don't start off in C++. In JUCE, you start off in C++. Everything in JUCE world starts C++ native. But if you're coming from a application developer perspective on iOS or Android, you're not really starting in C++. So I'll get into that later in the talk. Great, so we knew that we wanted to build better vocal effects. We knew that we had some super collider code that we wanted to start implementing into DSP. And so we started with audio unit v3s. There's this great little tutorial by Apple called Creating Custom Audio Effects. If you haven't, if you're an iOS developer and you haven't tried to build a custom effect, I highly recommend just going through this tutorial. You end up with targets that kind of take your AUV3 audio unit and let you add that into the rest of your project. So it's very easy to get started building audio effects. But it also turns out that Aurelius, who's sort of the author of AudioKit and is an amazing person, has also, with AudioKit v5, made it very easy to just build audio effects right into the rest of your code. And so if you're using AudioKit already and you want to start getting into DSP, it's actually very, very easy. You just sort of use a couple of these macros and you're all set. So we started going into that direction, building these custom voice effects more easily. And in that case, you have sort of an effect that isn't part of the standard library that you're going in and writing, and you just have to make sure that you build an audio unit container subclass and that you override this create DSP subclass, and that's where you take your C++ code and make sure that you can bring it into the rest of your graph. And so this basically allowed us to easily start building audio effects without having all these separate targets. And I'm sorry about my keynote skills. I've animated things in a random order. But we're here. Oh, never mind. Now we're here. Cool. Awesome. So we have now custom vocal effects, right? And we could build these in Faust. We could build some of them in Chuck. We could play with Soul. We were playing with pitch shifters like Rubber Band and Elastique, but we wanted to also build our own custom voice effects using our own sort of libraries. And so I reached out to a really great audio programmer, artist, Mike Mulshine, who's a student at Karma. If you haven't seen this hairdresser film of his, it's amazing. But he also worked on a library called Leaf, which is a lightweight embedded audio framework. It's a really simple set of tools written in C that make it easy to just build sample by sample effects. And so if you haven't played with Leaf, or if you're looking for something that might be fun to help bootstrap your DSP code, it helped us build a lot of effects really quickly. But it's also just a simple C library. Cool. So vocal effects we had. We started writing a lot of vocal effects. We had vocal effects. Now the other piece of the puzzle was how do we create better editing tools? Again, the creators on the platform wanted better tools. We had a graph that looked like this, meaning like we had started with a very simple graph like I had demonstrated before, and over time we are just adding in compressors, equalizers, de-essers. What else do we got? Shelving filters, low-pass filters. So we have a large chain that we're building, and it's all organically growing in AudioKit, and it becomes very difficult to actually discuss what a project file should be when you're organically growing your audio graph, and every time you have a project file, it has to be updated given the fact that your graph might change. So we started taking a serious look at traction. Kieran, what's up? And because of that, we actually were able to get a lot of excitement around building these really high-quality editing tools. So we started exploring it, and the first thing we came up across was like, do we have to build this whole app from scratch? Using sort of the JUCE UI. Is there a way somehow that we could get native UI working with it? And luckily in 2015, there was a series of great talks from two great audio developers. I highly recommend you check these out. Leo Oliver, Adam Wilson, both sort of got into the details of how to get JUCE working with native UI. And so we actually had a JUCE and native UI working demo here. Oh, good. So I have this playing. But we could now have large projects where we could trim and move around different clips with native UI, which was really exciting because, again, before we were working with our own idea of a DAW abstraction, and now we kind of had the tools to really not worry as much about the DAW abstraction. So bringing JUCE and Traction Engine into a native project sounds, I think, a little bit more scary than it actually is. The biggest point is you have to compile some sort of library that you build into the rest of your project. That C++ layer communicates through Objective-C or on Android through JNI, and you just create wrappers and you make the API surface the same as you have for your native iOS code or your native Android code, and you have the underlying functionality that you need on mobile. So this is kind of bringing all that together with Traction Engine. You can now edit a song, and if you go into the mixer page, you have the, and that doesn't really illustrate maybe the full depth of it, but you have basically the entirety of the features of a DAW inside of a mobile app that you can start playing with, building sort of very complicated project structures with different racks that are allowing you to modify the plugins. So we unlocked a lot of potential by just embracing JUCE and Traction Engine. So a couple things that we were able to start doing. We have richer editing experiences. We could manage larger projects for users. We could start doing audio development outside of just the iOS project, which meant that we could basically have audio developers who don't want to touch mobile, which how many people here do not want to touch mobile for audio? Only one? I think there must be more. Yeah, I'd imagine. So using something like this allowed us to start building separate targets for testing or for our GUIs so that we could really start developing plugins separately from the rest of our iOS code. We can start developing vocal effects change that way. And we can also start developing more creative recording tools that aren't as limited by our ability to kind of dream up all these graphs that before were things that every time we wanted a new feature, we just have to build a completely new audio graph. Cool. So just an overview of what I'm discussing today. Again, this is a very high-level technology-related talk. But I just wanted to say, if you're coming from an iOS background, if you're like me a year and a half ago, these are the technologies that I think are just going to unlock a lot of potential in getting you started in audio development. First one being AudioKit. Highly recommend it. Makes audio development crazy fun. And it's really easy to build DSP effects using it. Faust, again, a lot of the effects that come with AudioKit are actually Faust code that have been compiled and built into AudioKit. So if you get started with Faust, it also makes it really easy to start playing with audio effects in your audio graph. Super Collider for prototyping, I highly recommend. And then obviously JUCE and Traction Engine. Even though Traction Engine is still a little bit new, it's only been sort of out in production for about a year or two. David Rowland is exceptional and is a pleasure to work with. Oh, there you are. Hey, cool. So special thanks to a few people. Leo Olivers, Adam Wilson, Mike Mulshine, Jeremy Klein, Andre, and Ryan, who have all been helping in various ways to get the project moving and helping make this dream of a mobile DAW that actually people would want to use real. And that's kind of where we're heading, and that's what we're excited to get to. This is a picture of some of the people on the team. So we are not just focused on building audio tools, we are also focused on building community on the app and supporting sort of the beginner musician. And so a lot of the people who are helping make this dream possible are coming at it more from the community side or from the marketing side to help people realize that on their phone, if they can make videos for TikTok, they can certainly make certain songs for TikTok as well. And then again, just a huge thanks to a number of audio developers in the community who've just been there to really help us along. Yeah. So if you're intrigued, this is my final slide. Either talk to us on Twitter, talk to me on Twitter, email me. Yeah, thank you.
What were your main takeaways from you, like using Faust or Super Collider? When would you recommend using Wedge?
I think a lot of the discussion in terms of audio developers is focused on how do you perform a task in a really efficient way, or how do you make something work that might be complicated. But I think the idea of dreaming of effects before you build them is an important part of it, especially if you come from the idea of building plugins. What's the ideation step like? How do you think about the plugins you want to hear? How do you start getting a feel for that before you actually invest in building it? Do you focus too much on the details of it, or do you allow yourself to kind of dream? And if you find yourself asking those questions, I highly recommend playing with Super Collider. Obviously, there are many tools for prototyping that are great. But I just think that the community around Super Collider with the UGens is just a really awesome resource that I hope everybody can use.
Cool, thank you. Oh yeah, we have to ask questions through a microphone so that people attending online can hear us. So let me just pass it to you.
Yeah, I just wondered if you could say a bit more about Traction and how that really fit in. It wasn't totally clear to me what that was, what you were getting from Traction.
Yeah, Traction's been actually really great. So in terms of just like managing plugins, thinking about clips and abstractions there, if you play with the waveform DAW, it's a free DAW, and it makes it very simple to know about the constraints of the technology, about what you can and can't do. So Traction Engine is the engine that supports waveform, and it's actually makes it very easy for us to sort of describe high-level DAW functionality without having to build each of those feature sets ourselves in either our own CoreAudio render callback loop or in AudioKit. So it lets you just get started with a lot of abstractions that are useful in thinking about building a DAW, if that makes sense.
So it seems like the kind of purpose of the app is for sort of beginner musicians who don't know a whole lot about audio processing and maybe don't know all of the terms and things. So I'm just wondering how you kind of manage having what looks like quite a complicated FX chain and using traction graph and everything, and then kind of translating that to a UI that's really like simple for a user to come in and understand.
Yeah.
Who doesn't necessarily know about resonance and cutoff frequencies and
Exactly.
so on. So you have a lot of like kind of multi-parameter controlling.
Totally. So we have to basically build all that functionality in, provide it. I think we'll provide pieces of it to more advanced. If there is a group of more advanced producers who want to come in and actually see and tweak parameters, that's something I think we're open to. But to get started, I think we just provide the full functionality that you'd expect from a DAW and then try to hide as many details of it as possible so that it's more just playing with vocal effects or playing with, I didn't go through this, but we have a way of just changing the overall mix and master of it, where you just press a button and we just change a variety of different settings to try to make things sound good. So it's really about trying to reduce the burden of sort of complexity on the beginner user, but the complexity still needs to be there for the audio quality to be high and for the experience to be real in terms of getting the experience of building your audio project. So we build actually our own project files, but over time, I think working together with actual tools, like allowing you to move your project file into something like Ableton or FL Studio, is something we definitely want to be able to do so that you can work with a producer, given that the tool is mostly for beginners and vocalists.
Any more questions? Oh, yes, sir.
I was wondering how early in your MVP and prototyping process did you involve the user? And how much was it you dreaming, like you said, and showing the user? And how much of it was them telling you what they want or what they like and they don't like? How did you navigate that space?
We started doing user testing immediately. So from the earliest prototypes, we started bringing people in and having them use it. And we talked to a lot of people who would respond to an ad saying, do you want to make music on your phone? And people who said yes, we were like, great, here's an app. Play with it and let us know what you think. And from that, we've every week just been collecting feedback from them. So somebody on the team is dedicated to interviewing users and figuring out what works for them and what doesn't, or seeing them play with it. And oftentimes, their feedback just directly impacts what we work on the next week. Yeah.
There you go.
Cheers. Thanks. So you mentioned a bunch of different frameworks and tools, a lot for kind of the early stages prototyping. Have you settled on a final set now that you're using, or do you still kind of have to go from C++ to different languages through bindings, or have you kind of replaced them with one thing?
I would say that we are increasingly moving to one thing. So I think the fact that with JUCE and Traction Engine, we're able to develop on desktop is a big piece of it. And the fact that we know that one day we'll be able to move that logic to Android is another big piece. So we are definitely leaning much more strongly in that direction. And I think excited to release more features using that tool. Right now, just because we have sort of a limited sized team, we're still maintaining a previous sort of technology for the recording environment. and slowly moving the editing tools over to Traction. And I think once we sort of test those out and get a feel for them and see how the users feel about those increased sort of technical things that they can do, I think we're excited to move more logic into C++.
Okay. But you can interoperate with all of these at the moment?
Yes, yeah. So we have both right now in the app.
Thank you. One more question.
I've got a question about the sound instruments. Do you have any different instrument libraries, and how do you deal with that?
That's a great question. So again, I think given that we sort of are starting out, we're focused mostly on the vocalist. And so I think over time, thinking about how to allow people to make simple beats in the app, something we're interested in. Just to start, I think there are many apps in the App Store that are focused on samplers and sequencers and that do a very, very good job and that are very difficult to actually compete with in that space of coming up with a really high quality sounding beat. So I think where we kind of made sense of it is if we focus on the vocal effects and the vocalist, that seems to be a space that isn't as crowded from the perspective of like other apps on the store. But I do think that over time, it's something we want to explore more. But right now, we work mostly with produced beats in the app. So we work with producers who make their beats in Ableton or FL Studio and then bring those into the app.
Okay, any more questions? I just double check. Oh yeah, there we go.
Do you have a lot of users trying to use your app with Bluetooth devices like AirPods? And how do you deal with the latency issues when editing and recording?
Oh, yeah. Yeah, so that's a great question. So AirPods have around like 200 milliseconds of latency sometimes. And so it's actually a huge thing that we have to compensate for, where during the recording experience, if you want to turn monitoring on, we allow you to opt in if you have AirPods or other Bluetooth headphones. And then we try to compensate for that in the review page by understanding the latency at the time, like the operating system will give you a sense of what the input latency and output latency are, and then we adjust based on that. So there are ways that we're working around Bluetooth headphones, but we don't have like a seamless live monitoring experience with Bluetooth headphones. And I'm not sure if someone has solved the issue of live monitoring with Bluetooth headphones and making that a seamless experience. I would really love to talk. But we basically compensate for it in the review page and in the recording page. If you turn monitoring on, you hear it delay.